Hey there, year 11s. This is now to do with inverse functions. It's a really important component for next year because often it comes up in the exams, even though it's only a few marks, maybe 5 marks in total. But here we go. The set of ordered pairs 1, 2, 3, 4, 5, -1, 6, -7 is a function. So they tell you it's a function. If it's a function, that tells you that we know it can either be a many to one function, or we know it can be a one-to-one function. Okay, so there are two possibilities there. Now they say that describe the inverse function of this function as a set of ordered pairs. Give the domain and range of both f and the inverse. All right, so let's visualize what these sets of graphs look like. So then you can describe the inverse function or not. Okay, so let's put the axes here, 1, 2, so 1 is here, 2 say there, so I've got my first point. The next one is 3, 4, so 2, 3, maybe 3 is here, 4 say double that, so 4 is here, so 3, 4. Then you've got 5, -1, so maybe 5 is about here, so 5, -1, so maybe there. So here's my next point, and then what's my 6, -7? Ooh, I'll do 6 here. 6, -7, say, it should be a bit further down, but that's okay. I'm just going to quickly do that. And then -7, let's just say about down here. So there's my next point, 6, -7, and then 0, 6. Ooh, 0, 6. When x is 0, y is 6. So that goes up here, say up here. I know that's more than 5, but let's just say 6. Okay, so that's my 0, 6 there. Okay, so let's put in the dot point. So we've got this point, this point, this point, this point, and this point. Okay, so that's my set of relations, but this is a function. So it is a many to one or one to one. Maybe it's more likely to be a one to one. And now it says describe the inverse function. So when you do an inverse, remember you are essentially saying the inverse. If you didn't realize here, I'm just going to show you an example. I'm sorry. The x and y values, when you talk about an inverse essentially does this. X, y coordinates. Any xy coordinates now becomes yx, and that's simply because the x equals to the y and the y equals to the x. That's what an inverse function is. Okay, and in my video of the theory, I would have explained why that is true. But here, if that is the idea, x becomes y and then y becomes x, right? Then our coordinates would now become 1, 2 becomes 2, 1. 3, 4 becomes now 4, 3. And then what's this? 5, -1 now becomes -1, 5. And then 6, -7 becomes now -7, 6. And then finally 0, 6 becomes 6, 0. If you plot these points in, you'll find there's something interesting. So 2, 1 would imply that you go across 2 and then 1. So it's over here. Can you see there's a bit of a mirrored image right now? I'll mention a bit more of it. 4, 3. So 4 is over here now, and 3 should be about here. And I probably should have drawn it on a proper axes, but it's okay because I didn't label it properly, so it probably won't turn out as I would like. But I'm hoping that you can see a bit of symmetricalness to it. So notice here, I'm going to do a different color here. This is 3, 4, and then when we swapped it, it becomes 4, 3. But can you see that there's a similarity here? This was 1, 2, and then it becomes 2, 1. Can you see they're actually quite mirroring in the sense that they're not too far away from each other, are they? And then let's have a look at the other one. 5, -1 becomes -1, 5. So 5, -1 is over here, right? Watch what happens. So -1, what is it? -1, 5. -1, 5 is now over here. -1, and then 5 is about here. So can you see that sort of correlation? See that? How they're just opposite each other. So when it's, see how they're just opposite each other, opposite each other, opposite each other. That's what's special about the inverse function. Okay, and essentially, when you say this, x equals y or y equals x, you're actually doing a reflection, not on the x-axis, not on the y-axis, but you're actually doing a reflection in the y equals x line. That's essentially what's happening. It's getting flipped over that line. Okay, so it's getting flipped over. It's getting flipped over. So that's why at 606, you can see that it's going to flip over and it's going over this side. So let's have a look. From 06, can you see 06 becomes 60, which actually 60 is over here. Why isn't it choosing my color? Here, this is my point. Can you see how it has moved from this point to this point? It kind of jumps over that mirror and it's mirroring each other. Can you see that? So that's what the inverse is actually doing. And you can see with this point, obviously it's going to jump over here. So let's see. It says 6, -7, and it becomes now -7, 6. So -7 is over here. Let's just say about there, -7, and then 6 would be up here. Can you see how they both jump across to each other? So it's a mirrored image, but across the y equals x line, and that's essentially what you can see. And if you were to then describe the domain and range for both the f function and the inverse function, so if we were to do a table, right, the domain and the range of each, you can see the domain for the red one. The domain was clearly from 0 as the lowest x value to the largest x value is clearly 6. So clearly the domain was from 0 to 6, even the integers. Okay, so 0 to 6, that's my domain. This is not a really good way of describing it, but I'm just going to do 0 to 6. That's not really true, because that means that you can have half and all that, but assuming they're all integers, saying that it's an element of integers, then 0 to 6 is what you can have, and the range is clearly from -7 all the way to 6. Okay? Whilst, if we have a look at the range and domain for the F inverse, so the blue dots, look at the blue dots. What are my x values? What can it take, right? This is where it's special, and you'll see the properties come in to play. Ooh, I just deleted everything. That's okay, I'm going to use another color. Let's do cyan, okay? Let's have a look. Now, if we go for the x values, can you see the blue dots? The furthest it'll go is up until... where was it again? Oh, because I highlighted, I can't tell what... This should be a blue one. So from 6 all the way to -7 there. Okay, so my domain now is for the blue, clearly is from -7 all the way to 6. And then if you look at the y values for the blue section, can you see the smallest y value can only be from 1, okay, all the way up until 6 is the highest value. So, is it 1 or 0? Oh, sorry, no, it's down here. I keep forgetting that there's a blue here. So it's 0 to 6. And what's actually happened, can you see, not only when you flip it over the axes, it also swaps the domain and range. Can you see there? The domain of the function, now, I'm going to do it in color so you can see, the domain of the function is now the range of the inverse, and then the range of the function becomes the domain of the inverse. And that's a special property that you must know. And that links back to this point here. Domain of the inverse becomes the range of the function, the range of the inverse becomes the domain of the function. Everything gets flipped across this mirrored line. Okay, so that's essentially what they tried to get you to identify. The point of all that was really just to get you to understand what an inverse function is. okay, or inverse in general. What does an inverse do? So there are two properties there. Not only the x and y values switch, but the domain and range also switches. That's what you needed to describe. Okay?